In this video, I will discuss about a problem based on numerical aperture. So let's start this video. So I have written a problem. The problem says numerical aperture of step index fiber is 0.39. So numerical aperture of optical fiber is given as 0.39. Now diameter of core is 200 micrometer. The angle of acceptance when fiber is used in water. If that optical fiber is placed in water, then acceptance angle will be. See, the relation between numerical aperture and acceptance angle is numerical aperture is equal to n naught sine of acceptance angle, where n naught is the refractive index of medium in which optical fiber is placed. In most of the problem, optical fiber is placed in air. So refractive index of air is 1. So we simply write numerical aperture is equal to sine of acceptance angle. But the actual formula is numerical aperture is equal to n naught sine of acceptance angle, where n naught is the refractive index of a medium in which optical fiber is placed. So numerical aperture is given as 0.39. N naught refractive index, it is placed in water and the refractive index of water is 1.33 sine of acceptance angle. So acceptance angle will be 0.39 divided by 1.33. Sine inverse of this value. So sine inverse of 0.39 divided by 1.33. So acceptance angle will come out to be 17 degree. So this is the maximum angle at which light can enter. So acceptance angle is 17 degree. Thank you.